What if you could compress anything into a black hole? Imagine taking any object in the universe, a rock, a drop of water, a mountain, or even a human being. Now imagine squeezing it smaller and smaller until it becomes so dense that not even light can escape. It sounds like science fiction, but according to Einstein's theory of gravity, it's mathematically possible. Every object has a critical size called the Schwarzschild radius. As long as the object remains larger than this limit, it behaves normally. But the moment all of its mass is compressed inside that radius, everything changes. Gravity becomes so intense that nothing, not even light, can escape. The object is no longer a planet, a star, or a person. It has become a black hole. Around it appears an invisible boundary known as the event horizon. Anything outside this boundary can still escape. But once something crosses it, there is no way back. Not matter, not light, not even information. According to our current understanding of physics, this is what makes black holes some of the most mysterious objects in the universe. And here's the surprising part. This limit doesn't only apply to stars, it applies to absolutely everything, even you. Let's start with something familiar. Imagine a person weighing about 75 kilograms. If you could somehow compress every atom of that person's body into a sphere smaller than their Schwarzschild radius, they would become a black hole. So, how small is that? Only about 10 to the power of minus 25 meters. That number is almost impossible to imagine. For comparison, a proton, the tiny particle inside every atom, is about 10 to the power of minus 15 meters across. That means you'd have to compress a human being into something 10 billion times smaller than a proton. According to everything we know about physics, that's impossible. But mathematically, the numbers work perfectly. Now let's think bigger. What if we compressed the entire Mediterranean Sea? All that water would fit inside a black hole with a radius of only about 6 nanometers. That's roughly the size of a single protein molecule. Now take the entire Earth, mountains, oceans, cities, every living thing. Compress all of it into a single point smaller than its Schwarzschild radius. And our planet would become a black hole with a radius of just 9 millimeters. An entire world, reduced to something about the size of a marble. It's one of the strangest ideas in modern physics. The amount of mass stays exactly the same, only the space it occupies changes. You might think that once a black hole forms, it exists forever. Surprisingly, it doesn't. In 1974, physicist Stephen Hawking proposed that black holes slowly lose energy through a process now known as Hawking radiation. This means black holes gradually lose mass over time. And here's the strange part. The smaller the black hole, the faster it evaporates. A tiny black hole made from a single person would survive for only about 35 trillionths of a second before disappearing completely. A black hole with the mass of a 40-ton truck would last only about 5 milliseconds. A Boeing 747 would survive for roughly 7 seconds. An Eiffel Tower black hole would exist for about 1 day. A Titanic-sized black hole would survive for around 140 days. Even a massive aircraft carrier would completely evaporate in only about 2.7 years. But the ending is the most dramatic part. When a black hole finally evaporates, the mass that remains is released as an enormous burst of energy. Thanks to Einstein's famous equation, E equals mc squared, we know that even a small amount of mass contains an astonishing amount of energy. A black hole made from a single person would release energy comparable to dozens of Tsar bombas, the most powerful nuclear weapon ever detonated. A truck-sized black hole would release the energy of thousands of Tsar bombas. Larger objects would unleash millions more. Fortunately, creating black holes this small is far beyond anything humanity can do. For now, they remain fascinating mathematical possibilities rather than real world. Now let's imagine something truly unbelievable. In an instant, the entire Earth is compressed into a black hole only 9 millimeters across. The oceans are gone. The continents disappear. Everything that ever existed on Earth is now packed inside something no bigger than a marble. So what happens next? Would the moon spiral into the black hole? Would the solar system collapse? Surprisingly, neither. Here's why. Although Earth's size has changed dramatically, its mass has not. And gravity doesn't care whether that mass is spread across a planet or squeezed into a tiny black hole. As far as the moon is concerned, Earth's gravitational pull is exactly the same. That means the moon would continue orbiting almost exactly as it does today. The same is true for satellites. If they were already in stable orbit, they would continue orbiting normally, provided they stayed far from the tiny event horizon. The sun wouldn't notice the difference either. Earth would continue circling the sun once every year, just as before. The only real difference is that Earth would no longer have a solid surface. Instead, there would be a black hole smaller than a marble where our entire planet once existed. If you got too close, the intense gravity near the event horizon would be fatal. But from thousands or even millions of kilometers away, gravity would behave almost exactly as it did before. It's one of the strangest truths in astrophysics. A black hole can completely replace a planet without changing the motion of the objects orbiting it. If Earth can become a black hole the size of a marble, what happens when we compress something much larger? Let's start with Jupiter. Jupiter is the giant of our solar system. In fact, it contains more mass than all the other planets combined. Yet if we compressed all of Jupiter into a black hole, its event horizon would have a radius of only about 3 meters. That's roughly the size of a large van. Now let's move to something far more massive. The Sun. Our star contains about 99.8% of all the mass in the solar system. It's so enormous that more than 1 million Earths could fit inside it. But if the Sun collapsed into a black hole, its event horizon would have a radius of only about 3 kilometers. Imagine squeezing an object nearly 1.4 million kilometers across into something the size of a small city. That's how incredibly dense a black hole is. But here's where things get even more interesting. A black hole doesn't have to stay the same size forever. It can grow. As gas and dust fall toward it, they become trapped by its gravity. If a nearby star gets too close, the black hole can strip away its outer layers, or even consume the star completely. Sometimes two black holes collide and merge. When that happens, they create an even larger black hole and release enormous ripples in space-time known as gravitational waves. Over millions or even billions of years, these cosmic mergers can transform ordinary black holes into some of the largest objects in the universe. And that's where our journey is headed next, because the biggest black holes are so enormous that comparing them to planets, or even stars, no longer makes sense. Everything we've talked about so far has been theoretical. But what about the black holes that actually exist? Astronomers have searched the universe for decades. And so far, they haven't found any naturally occurring black holes with only the mass of our Sun. Current evidence suggests that a star usually needs to leave behind at least 3 times the Sun's mass after it dies for a black hole to form. Even then, the result is astonishingly compact. A black hole with 3 solar masses would have an event horizon only about 9 kilometers in radius. Think about that. 3 suns, compressed into something smaller than many cities. The closest known black hole to Earth is Gaia BH1. It's located about 1,560 light-years away, making it our nearest known black hole neighbor. Despite containing almost 10 times the mass of the Sun, its event horizon is only about 28 kilometers across. That's smaller than the width of many metropolitan areas. But there are even bigger black holes that bridge the gap between ordinary stellar black holes and the true cosmic giants. These are called intermediate mass black holes. Astronomers believe they form inside extremely dense star clusters, where countless stars collide and merge over millions of years. One of the best-known candidates is HLX1. It is estimated to contain around 20,000 times the mass of the Sun. Even with all that mass, its event horizon is only about 59,000 kilometers in radius, roughly comparable to the size of Jupiter. Some studies suggest HLX1 could be even more massive. If those estimates are correct, its event horizon could stretch to nearly 300,000 kilometers, large enough to dwarf planets, yet still tiny compared with the enormous scales of galaxies. But even these black holes are only the middleweights, because next, we're about to meet the monsters that rule entire galaxies. So far, we've seen black holes that formed from dying stars. They're incredibly dense, but they're only the beginning. Every large galaxy is believed to hide something far more terrifying at its center: a supermassive black hole. Our own galaxy, the Milky Way, is no exception. At its heart lies Sagittarius A star. This cosmic giant contains about 4.3 million times the mass of the Sun. Its event horizon stretches to roughly 12.7 million kilometers. That sounds unimaginably large. But in astronomical terms, it's surprisingly compact. If Sagittarius A star replaced the Sun, its event horizon wouldn't even reach Mercury's orbit. The entire monster that controls our galaxy would still fit comfortably inside the innermost planet's path. Now let's go bigger, much bigger. Meet M87 star, the first black hole ever photographed by humanity. It contains about 6.5 billion solar masses. Its event horizon extends nearly 19 billion kilometers from its center. If M87 star suddenly appeared where our Sun is today, Mercury would disappear, Venus would disappear, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Even Pluto would be swallowed whole. The event horizon would stretch far beyond the edge of our planetary system. Only one human-made object might survive. Black holes are more than cosmic curiosities. They are nature's ultimate demonstration of gravity. Objects so dense that they bend space and time to their limits. From a human compressed into something smaller than a proton, to Earth shrinking into a marble, to the Sun collapsing into a sphere only a few kilometers wide. The numbers seem impossible. Yet they all follow the same laws of physics. And then come the giants. Black holes so massive they anchor entire galaxies. Monsters like Sagittarius A star, M87 star, and TON 618 remind us that the universe operates on scales far beyond everyday experience. The farther we look into space, the stranger reality becomes. Every new telescope reveals objects that challenge our imagination. Every new discovery reminds us that what we know is only a tiny fraction of what's far greater than anything we can truly imagine. Follow FactVerse for more amazing facts.